Page Freezer is a company. Page Freezer is a company in the US, in Canada, who is trying to solve a problem around archiving. So trying to archive people's social media sites, social media accounts, archive websites. Prior to joining Page Freezer, I used to work at Brightcore. Brightcore is a company in the US. It's a company that builds SaaS solutions for insurance companies. I've been there for about 2 years and like 8 months before I joined Page Freezer. So I've been in Page Freezer for like 3 weeks now. AWS certified, at least I have all the associate level certifications. Still planning to write the professional level, the certificate for professional level. When I'm not coding, I like to play snooker, table tennis, and spend time with my son, who is about 1 year, 7 months. So for the business of the day, we'll be talking about CICD. I don't think this term is when you type CICD on Google, I'm sure you get a lot. Like there will be a lot you get from Google when you type CICD, but it's really simple. The whole idea is that we know DevOps is about development and operations. And so CICD just bridges that gap. So if we say we want developers to be able to connect to operations, how does that happen? That's where CICD comes in. So we're CICD just helps you to bridge that gap. So it helps developers push their code to the people that need it, whether it's QA, whether it's production, whatever code needs to get to. So whatever deployment needs to get to, CICD does that for you. In actual definition, it's just the practice where you are doing CI, which is continuous integration. We're going to look into that in details, both in theory and practical, continuous delivery, and then continuous deployment. So all that together makes up CI/CD. People confuse continuous delivery with continuous deployment, but we are going to see the difference between the two. And like I said, it just bridges the gap between development and then the operation itself. And then what CI/CD can help you do is automate the building, the testing, and the deployment of your application. So there's always that problem as a developer where you build stuff, and then you're thinking about how will this be deployed. So the work of CI/CD, which is mostly handled by Devops Engineer or cloud engineers or infrastructure engineers, is just to ensure that the code from the developer gets to production. Production can be so many things for so many people. It could be a site where it needs to get to before it is moved to production. It could be a QA site, but the whole idea is just how does code leave the the developer's laptop. In some cases, it could just be moving it to somewhere where other developers can test. So if you want you want a site where the team can test and ascertain that things are working as they should before it moves to production, CI/CD does that for you. What are the benefits? So many. With CI/CD, you can actually detect bugs faster, and it's quite simple because you as a solo developer, you are just interested in your laptop, like how it's working in your laptop. But there are so many other things that is involved for you to build something that is of quality. So you have to do things like, run your integration test. Sometimes you also need to actually see how it works in the, more or less where it's going to live. So if it's going to live on AWS, is it possible we have a site set up on AWS that we can test the changes? That can allow us to detect bugs faster instead of just say, oh, let's push it to production, But if there's a site in AWS where we can push it and we can test, yeah, we can do that. I can test, fellow developers can test, the QA team can test, and then we can have both automated and manual tests if you want to. And then before, with that loop in place, you can actually catch, it's easy for you to just detect where there's bug. And then, of course, there's increased productivity for developers because the fact that you can quickly test, it helps you to iterate very fast. So the fact that you can push it and then you see it being deployed out of your local machine, and then you see it at work, and then you test it, that can, boost productivity on your own end. And then obviously the release cycle is one of the things that is very, very important as a benefit for CI/CD, because what it means is that you can roll out your changes to the end user faster. So if there's already a CICD in place, what it means is that if the developer pushes code, it is certain that it's going to get to the end user faster. So the release cycle, so some people, they release daily, some people do bi-weekly, some people do, like, you can choose your own release cycle, but the good thing about it is that CICD gets that covered for you. And although this, I don't know if you can see this small diagram, is quite small, but there's just a small diagram that talks about CICD. And obviously CI, which is continuous integration itself, talks about the plan, where you plan, where you code, where you test, and where you build. And then when you talk about continuous delivery, you are also talking about the deploy step, the steps where you're monitoring it, and the steps where you're doing further operations on it, and then you're optimizing the pipeline. We'll discuss all that as we progress. So that brings me to continuous integration. Continuous integration really is just you automating the building and the testing of the code. So as a developer, you have a code that is working, and then you need to push your change. So this mostly talks about the point where you are relating with so when you talk about continuous integration, there is a collaboration involved. So maybe you're talking about code commits, or you're talking about GitHub, or you're talking about Bitbucket. So the whole idea is how you integrate code. So in this case, some people use master as production branch in code. Some people use other convention, but so how you integrate code back to master is what we call continuous integration. And for a lot of cases, you want to run some tests, you want to build it, you want to build the entire package, you want to test it, you want to deploy it, you want to see how it works. How that code is integrated into the master branch is, or the production branch, or the branch you say, this is the branch I want the end users to see, is what we refer to as continuous integration. So it involves the steps around testing, your building of the code, and then source control has to be involved, because you are integrating your code into a larger code base. And so everything that has to happen for that to take place is what you call CI. And the good thing about CI is that it allows, and CI, continuous integration itself, is that the beauty about it is that it allows you to detect bug at multiple fronts. So for example, you could have like GitHub Actions that does some initial check for you. And then when you push code to your, for example, your branch, for example, like you have a PR opened, like you want to merge this PR. And then for that branch that you open, you can say, oh, there's a policy that says you have to move it to development first. When you move it to development, the pipeline runs, and that pipeline decides if this particular code or change that you're trying to introduce, if it meets all the steps or all the standards that have been laid down. And if it does, then good, we can integrate the code into master or production, as the case may be. And again, the beauty of it is that we can detect if there is already that as a CI process, it means we can actually detect problems faster, because you know that before you introduce the change to master, we would have caught it on different fronts. You could have CICD that runs some small tests. You could have some other tests that takes the code to AWS and see how it functions in real time if it is taken to AWS. And then again, one benefit about that is that developers, it's easy for them to get, like there's a faster feedback loop. So if there's already an automated test at the source control level, and there's already an automated test on the AWS account, or like on the AWS site itself, it is easy for you to, send back feedback immediately to say, oh, I tested it in QA, it's not working, or it's broken in QA, or it's broken in development. And that's really what CI is all about. And then CI itself is just a number of steps. So when all these things are happening, we are still talking about CI. So the planning itself, the planning has to do with, you might have like, we have to work like sprint. A lot of people do sprint, 2-week sprint, so you start your sprint and, you say, oh, we'll build all this stuff within the sprint, and then we push out code. So all that is part of the CI, because planning is involved. And then it's during planning, we know, oh, this is how we release code. So do we release code every 2 weeks for our team, or do we release code after every 1 week? So all that makes up the planning process itself. And then there's actually the coding part, where the developer himself, or, is on his own laptop coding. And that's also part of CI, because the good thing about it is that when you're coding, there are already tests you can run on your local machine. You can run those code, to verify that, you're not breaking any change. But CI just complements it, because when you push it to GitHub or you push it to Bitbucket, something else happens, for the integration itself to happen. But it's all part of the CI process. Because if you don't code, like if you don't write the code yourself in your local machine, it's not complete. And then there's the build process itself, because for every code that you push, there is a build that has to happen. For a JavaScript project, there's a build, and it's not going to be the same kind of build with a Python project. For a Java project, the build will be different. For any kind of project you have, there are builds that have to happen. So all that is part of CI, because before you can test, before you can deploy, you have to build the project. You have to be sure that, this project, is packaged, it's ready. So it's what can be deployed or what can be tested. And then there's the test part. So the test part itself just ensures that, are there unit tests that needs to run? Are there integration tests that needs to run? All the kind of tests that needs to run for that code to be integrated into, in quotes, your production branch. And then we have continuous delivery. So continuous delivery is just very simple. It's just the process of actually releasing code to production. So what it means is that if you push your code, for example, and it's done with the integration part, and then you merge to master, continuous delivery just ensures that that code gets to production. But there's a caveat. The caveat is that it won't get to the end user. Something that there has to be a manual process that triggers it getting to the end user. That's just what differentiates continuous delivery with continuous deployment. And you would also see it even in the hands-on. So the continuous delivery itself is just, what it does is that how the code itself gets to the end user, that's where continuous delivery comes in. So when you push code, it has been integrated and it moves to master, and then it is merged. How it gets to the customer, it should be an automated process. So nothing should happen. That whole flow should actually lead to a change that the customer can see. And it actually guarantees faster delivery of value to the end user. Yeah, because if I merge change to master, and I say I give it, I know the build process, the pipeline itself will take maybe 30 minutes. I can be sure that after 30 minutes, the customer is going to get the change. So it's nice knowing that just merging to master should guarantee that the end user is going to get the change. And then we talk about the steps involved in continuous delivery itself. There's the release process. So at the point where you merge, you are creating a release. So it could be release, it could be version 1, it could be version 2. But at the point where there's a merge, you've created a release, and then deployment happens. So deployment is actually whatever has to happen for the code or the change itself to get to the end user. So maybe it has to run a pipeline, and then the pipeline has to deploy. In AWS, there's so much you can do. It just depends on your workflow. And we're going to see all that during the course of the presentation. But the whole idea is that depending on your workflow, depending on what you are building, the deploy itself determines how the code gets to the end user. And then operate. Obviously, after deployment, you can have monitoring in place. You can have like some set of automations around the code itself that has been deployed. So you can say, okay, once this code is deployed, I want you to push a release to GitHub to say, we now have a new release, because why? We've successfully made a deployment. And then there's also a monitor and optimize it, which is not very common, but the whole idea is to improve on your pipeline. So you can get metrics, you can get data that allows you to improve on the process. So you can get data that you can possibly even use as another set of inputs to improve on your pipeline, just based on the metrics you've been able to gather. And then I talked about continuous deployment. Continuous deployment and continuous delivery, there's a thin line between continuous deployment. So if you merge a code, if you finish your continuous integration and you merge to master, and the customer sees that code immediately, that's continuous deployment. So it's going straight to the customer. Nothing has to happen. So the difference is that between continuous delivery is that continuous delivery, there's like an intervention for the code for the end user to see the change. But for continuous deployment, it is continuously deployed to the end user. So like I said in the slide, near real time. So the customer sees the change almost when you merge and the pipeline is done and the deployment is done, the customer sees the change immediately. Whereas for continuous delivery, there might be some checks that they need to do. Someone might need to go and verify stuff and then say, this change is good to go. And then the person says, I approve this change to go out to the customer. So that's just the difference. One is really automatic, like it gets to the customer once the change has been made. Yeah, which brings us to the business of the day. CICD on AWS. This is an AWS group, so we will be talking about CICD itself on AWS. How does it happen? I have an answer. AWS Code Pipeline does all that for you. So AWS Code Pipeline allows you, it gives you all you need to create like a pipeline that allows CI/CD to happen. But the beauty of Code Pipeline, AWS Code Pipeline, is that it entails doing so much. You can do a lot with it. There's almost no workflows out there that AWS Code Pipeline cannot do for you. Connecting to a GitHub repo, connecting to a Bitbucket repo, integrating Jenkins, running a Lambda function, running a step function, doing all sort of stuff, integrating with CloudFormation, doing service catalog deploy. You can do all that from Code Pipeline. So the whole idea is that if you're going to be building stuff on AWS, you rely so much, you will have to rely on AWS Code Pipeline to set up your CI/CD that says, I want to get code from here and I want to deploy it here. And then you do all the orchestration within that. And like I said, it integrates with your favorite tools. So your favorite tools, you could be, if you are using GitHub, you're covered. If you're using Jenkins, you're covered. If you're using some external tools, you're covered. You can actually integrate them too. Because during Code Pipeline, you can actually do some executions. You can talk to an external API. You can do all sorts of stuff. You can connect to your VPC within AWS, and then you can reach out, and then you can improve your pipeline as much as you want. Just whatever you need to support your workflow. And then obviously it supports delivery and improves the quality. Yes, because if we know that it is very easy for me to have a pipeline that just moves code from GitHub to the end user. I mean, that's something to have. So this was gotten from the AWS page. So this is just like a very one of the commonest CI/CD pipelines you're going to see there. So there's a developer in the middle. He pushes a change to the source. In this case, it could be GitHub. It could be Bitbucket. And then there's a build process that happens in the pipeline. So the pipeline itself has a source that gets the code from maybe GitHub, maybe Bitbucket, and then it builds it, and then it's maybe deploys it and tests it. And then if there's need for a manual approval, which is continuous delivery that I was talking about, somebody can say, oh, I want to check this and manually approve it. And then if that is good, it goes to the customer, and then the customer sees it, and then you improve on it.
I've not started.
When the customer sees it,
Igbineweke that wants to go and do it.
It brings the customer can actually add more ideas to it, make some requests, say, oh, there's a bug here, or there's something you need to fix, and then all that comes in as a change or an update or as a fix, and then the developer does that. So it gives us that constant, there's that loop, and that's the beauty of it, because all this can happen very, very fast. This was not very easy in the waterfall days where there was this long release cycle that you needed to obey. But with CI/CD, it makes it really, really fast. So for the demo, I mean, it's just very good. It's going to be very simple, but it's going to touch everything that you need to know about CI/CD. So for the app, it's a Nux.js app. I do Nux.js. I love Nux.js. So maybe I wanted to do something about just pushing Nux.js to AWS. And then, so the app itself is simple. So what the app is simply going to be doing is a Nux.js app that is already on my local machine. And then I just have to orchestrate how it pushes to S3. And then I'm going to serve it to my end users using Amazon CloudFront. And so very simple, very, very simple setup. But I think it gives you, it shows you everything. Most of the ingredients that you need about CI/CD is going to be demonstrated with this very small app. And then the pipeline to do that. So I'm a solo developer. So what I just built, a very simple pipeline, doesn't do much. Looking at how simple my repo is, and I'm the only one that is working on it, I just have 2 branches. So there's a development branch and there's a master branch. And then there are 2 pipelines for those branches. So I, as a developer, I could have a PR and I open and say, I want to merge this PR, but there could be a policy that says, before a PR is merged, you have to take it to development and we have to test it there. So what, in this case, I'm actually not creating pipelines per PR. Rather, I'm saying push to development first. Once it's in development, it's going to be deployed to AWS. And once it's in AWS, we would have run all the tests and we'll test it manually or do whatever kind of test we want to do. And if it passes all the tests, we say this PR is good to go, we merge it to master. And then when it goes to master, another pipeline, we run another pipeline, a master pipeline that guarantees changes move to production. So that's just a simple setup. So if you look at this diagram, from development, we get the code from GitHub, and then we take it to a code build, AWS code build, we run a test. From there, we move it to a build step where we build and package it. This is a Node, it's like a Node.js kind of app, but though I'm just using like the single page application part. So I just want to build a set of JavaScript files, to load to S3. So I'm not going to be doing much. And so once that is done, I'm also going to create a change set. A change set is going to create like a CloudFormation template that I'm going to deploy because I know I need CloudFront. I know I need some set of S3 bucket, depending on whether it's development or whether it's production. So I need to create that change set that says, I need a bucket because I'm going to publish my change to that bucket. I also need a CloudFront that is going to host my change. And then executing the change set is also just CloudFormation. So I'm just going to execute the change set from my from the change set that I've created. And then once that is done, I deploy the changes. So the executing the change set itself is just going to create a CloudFormation stack. And there's nothing much in there, but it's just going to create an S3 bucket. And then it's also going to create a CDN, which the end user is going to see for the development branch. Similarly, I'm going to replicate that for the master branch. So the master branch is going to do that. The only thing I just added there is just to show the continuous delivery path, which is an approve step. So the approve step is a manual step. So what it means is that a senior engineer, a lead engineer, someone who is more technical in terms of the product may need to go in there and verify that things are the way they should be before clicking the approve, because he knows that once he approves, it gets to the customer. So, that's just the difference between the development and the production pipeline. But in some cases, the difference can be much. You can have so many things in the production pipeline that is different from the development pipeline. For example, a successful production pipeline should actually lead to a release that might not be in the development pipeline. So there are a lot of changes that you can add to say this pipeline is a production pipeline, then we have to do these extra things and all that. But it's the same. It's just going to have an S3 bucket. There's also going to be a CDN, but this is a production CDN. And then obviously, if all that happens, and then when you deploy a development branch, who is testing that? It could be fellow developers, it could be a fellow QA person, it could be testers within the org, and then they're going to send feedback back to like say, oh, this PR, I think I tested it, it didn't work as expected. And then if it's a production, the customer may have to return back with feedbacks and all that. And it goes back as an idea or a request or a bug, and then it goes back to the customer. It goes back to the developer, and the developer can make those changes and then push it back to GitHub. And then, that cycle continues, as a continuous improvement process. I think that leads me to demo, because we've already talked about two pipelines. We've already talked about how it's orchestrated in AWS. I think it's time for me to show you something. So I created a repo for this, and the repo is here, DevOps Roadmap. I created a repo under my name in GitHub. So currently there are two users for this repo. So I created my user, who is I'm like the senior engineer who is responsible for merging changes. I also have another user who is pushing stuff. But if I check my AWS account at the moment, we don't have a pipeline. We don't have a pipeline at the moment. Yes, there's no pipeline in here. We don't have a pipeline. So we need a pipeline. At least for the development branch, we need a pipeline. So like I said, there's a set of instructions for you to deploy. But first, even before we create the pipeline, I need to see the application. So if I do, this is the application running locally. So how did I get to run the application? Just by running yarn dev. So the application is actually running on my local machine. So this is the application. But I need this same application to run on AWS. So because it might be working in my local machine, but what happens if we deploy it to AWS? So that's the question we need to answer. So I'm just a developer who is trying to do stuff on my local machine, but my local machine might not be enough for me to test, because I know eventually we're going to host this on AWS. So the first step, like I mentioned in this page, is that we first have to create a development pipeline. The development pipeline is what ensures that all the changes, we can test it in the development branch. So the first thing is that there's some set of artifacts that I created that we need. So for example, you need like a code build role, you need like a code pipeline role, you need like a CloudFormation role. All that is just to ensure that you have rules that helps you do stuff. And what that actually does is that it actually helps you to keep the principle of least privilege. So making sure that if I'm going to be doing stuff with AWS, I'm using the right roles to do it so that I'm not giving people too much permission. So like I said, how I started from this documentation, you create a free tier account. In there, you can create a new user that should be able to do this stuff. And within there, you can create like an artifact management stack. So in there, there's role for code build, role for code pipeline, role for CloudFormation. And then anyone that wants to do any stuff, my code pipeline can actually assume the code pipeline role. My code build can assume the code build role. And then if I'm going to be interacting with CloudFormation, I'm going to be using the CloudFormation role to do whatever I want to do. So we are just going to start with this. I'm just going to copy this and then try to, let me open another tab. So because I'm creating the development stack, let me just copy this and paste it here. Okay, no, so this is artifact management. So this will still apply for development or the production pipeline. So this should work for both pipelines. Oh, there's a stack already existing. Let me see, sorry. I think I need to. Okay, so the stack is already here. So I don't think there's need for me to create it again. Running that command should create it. Like it should create like an artifact management stack. But because I know we have less time, let me not bother doing it again. But the whole idea is very simple. If you check the resource, we just have a set of, like there's a bucket. The bucket is going to hold our artifact. An artifact in this case is like what we are going to be building. It's going to hold it. There's a CloudFormation role, like I said, that is going to hold, that's going to allow us to interact with CloudFormation. There's a code build role that's also that's going to allow the code build to assume and then do stuff. And then there's also a code pipeline role. So there's nothing much here, just a set of bucket and a set of IAM roles. So since that one is out of the way, what I'll just do is just to go to the next one, which is to create the service pipeline itself for the development branch. So I'm going to copy this. But one thing I need to make sure is I just need to be sure that for me to do that, if I'm going to be creating that for development, I just have to be sure that I'm in development because I want to create the branch for development. But before, sorry, let me just. Because I made some change to master, so let me just be sure it's here. So master is updated. So let me just go back to development. So let me just rebase development on master so that I have all the changes I want. Okay, so let me just merge. Of some conflicts. Let's see. Set. This. Setting content. Some current change. I'm just going to leave these as taking the current change. Happens in the it's been removed. Okay. Sorry. Yep. Setting comment change. Comment change. Okay. I think that's it for the README. Yep, that looks same. Let me just save this. Okay, I think that's it. Okay. So my development is updated with master because I made some change. So let's create a pipeline. So here I'm just going to create a new pipeline here, and that's going to be the development pipeline. So let me just differentiate it by just naming it DevOps Roadmap Development Pipeline. Let's see. Let's see. So if you check there, you see that I am actually creating it. I'm assuming a role. So the role ARN itself is the CloudFormation role. And like I said, that was what the first stack created. So one of the things it created is a role that allows us to like interact with CloudFormation, so that if I'm going to be doing any stuff with CloudFormation, I'm not going to be doing too much. I'm just going to be doing what I am allowed to do. So if you check CloudFormation, I think another stack should be creating, yeah, which is this one. So DevOps Roadmap Development Pipeline. And then there should be a pipeline. I don't know if it gets to that stage just yet. Failed. Okay, I know why. Okay. The pipeline is actually using GitHub version 2. So that allows, what that means is that there's a new connection it's using, unlike the old one where you had to use like an API key. So for this one, I have to connect it. So there's this, I have to just update the pending connection and connect it to my GitHub account. Yeah, so I need that for this to work. So that's different from the way the original API, the V1 used to work. So I'm just going to connect it. So it's connected successfully, and then I think I am good to kick off the pipeline again and just say release this pipeline again. Stop. So I think there's something wrong. I think I need to do stop and abandon. Yeah, why I did that is because my development is not in GitHub. So it's just in my local machine. I need to push those changes because the source itself is going to get from GitHub. So I need to push this to development. So when I push this, yeah, it's in development now. So now I can release the pipeline so that it will pick the new change that I made from master. So as you can see, you see that it picked the recent change. You can see the source itself is merge branch master into development. That was the recent commit we made. So it has pushed that. It has taken that from GitHub. And then what it's going to do, like I said from the diagram, so while it's building, it's going to run a test step. So the test step in this case is just everything that needs to test your front-end application. In this case, we just have, if I go to this simple application that I have, there's just a very simple test. It just says, I want to assert that there's a logo in the application that was built. So it's a very simple test, but you know, tests can be more advanced than this one. But the whole idea is that at the test step, we're going to run this test stage. So this is going to run it. How that is done is that we are using the test spec.yaml. So what it's simply doing is that we're using a Node 12 version. We are doing yarn install, we are linting, we are testing. So everything that has to do with, you know, testing, linting the files, you know, that's what your test step will do. So if that succeeds, then we can progress to like doing the actual build. And then also there we'll look at what is the build, what is it actually doing. So Jamu, how many minutes do I have? So let me know what to cut and what not to demo.
Okay, you have the floor. You still have about 25 minutes more.
Oh, good, awesome. So I think we still have time to go through everything I have here. So 25 minutes more, okay, thanks. So this is the test step. And one thing you should understand is that if you are dealing with pipelines, you have to be patient. Yeah, because you are dealing with AWS services, and sometimes your test step will take time. It depends on what you're testing. In this case, a small test, but you know, if you go and check the details of the test, you see it has to provision like a container that will do all this for you. All that will take time, you know. So it doesn't take too much time, but at least so you have to be patient. You just have to work, you know, wait. So while we're at it, I think it would be nice for us to start cooking the production pipeline so that we don't have to, but I'll come back and explain what this guy is doing. So for me to create a production pipeline. I just need to go back to master. So all this is going to happen. So if we already have pipelines, someone is going to create this. So someone is going to do your branch side of, okay, yeah, no problem. Let me just be sure. I think I've done that before. Let me just be sure that, yeah, so my master is up to date. So what it means is that everything is code, but if, I created a directory called infrastructure, that could be what a DevOps is doing. So it creates a pipeline for the product and ensures that when you move your change to master, we already have a pipeline that does all the deployment for you. So here, what I'm just going to do is that I'm just going to create that for the production pipeline. So I'm going to create, I think I can still get this from here. So DevOps roadmap pipeline, I'm going to create one. Remember, I'm in the master branch. So I'm just going to create another one for the master branch. So that's going to be creating. And so like I said, the test is done. The test is now done. So it has moved to the build step. Like I said, for every project you're working on, in this case, it's just a very simple Node.js application, not doing much. But if yours is a Java, then it's in the build step, you have to build the Java application. Why we're running the test before the build is, I don't want to build something that has not been tested. Why waste my time? So test it first if it's going to work, and then I go into the build step. So the build step is just going to build the application, whether it's JavaScript application, Python application, any kind of application. There's the build, code build supports everything because it just gives you like a box and you can do everything you want to do. So if you look at the build spec here, we're not doing anything fancy. Like if you see the build spec, what are we doing? First of all, I'm installing Yarn because I'm using Yarn in this case. And we're saying, I need a runtime version of Node.js 12. So the code build will give me a runtime that is compatible with Node 12. And then I'm also saying I want to install Yarn globally. Once that is done, I'll do Yarn install. Yarn install is just installing all the dependencies I need for that front-end application. And then I told you of an artifact bucket that we created for the artifact management stack. So what we are going to do is we're going to package. Remember that I said that whatever we are going to be building, we want to deploy to an S3 bucket and a CloudFront distribution, right? So that is going to give us like a template. It's going to give us like, when we package it, it's going to give us like a YAML file. So we need to package that. We need to send that to a bucket because we will need that eventually to deploy to CloudFormation, which is also another AWS service. But that's like, a tool on its own. But we are just adding all of them together to see how we can bring all of them together inside the code pipeline. So what this package is going to do is that it's going to package my infrastructure, template or YAML file, send it into the bucket and just leave it there. And then the step that needs it is going to get that bucket, is going to get that file and then deploy it for me. So that's just what the build has done. So the build has succeeded. If I go and check that bucket, I'm actually going to see the files that relates to development. Now, there is a release. The change set itself has been created. So change set is just, if I open like the infrastructure and I check my template is a very simple template. I just have a bucket. The most important thing there is I have a bucket and I have a CDN. But this is infrastructure as code. So my infrastructure itself, I'm not doing ClickUps. I expect that my infrastructure should be reproducible. So if I take this to another account, I should just be able to reproduce it. So I've created this template, and that's what we packaged. But after packaging it, it's living in S3. Now I need to deploy it because this YAML file, you can deploy it in CloudFormation. And so that's what the create change set is going to do. It's going to create a change set that says, I want to deploy this into CloudFormation. Will you allow me to do that? So that's what the change set itself is creating. So let me just go and approve the production pipeline. So that one is building while you see at the moment it has failed. We'll just have to do what we did before. So I'm just going to go to connections and I'm just going to accept the connection for the master pipeline. So in this case, it's also pending. So I'm just going to go, not sure, yeah, update pending connection. And then I'm just going to connect it with my GitHub account. So this is, if you are using the newer version of the source, connecting to like GitHub or some of these other source repos. So that one is done. So if I go back to this pipeline and I just release it again, it's now going to pick the change from master. But if you notice, you see that it's not going to be picking The same change that was picked there it was like we merged from master to development. This is going to pick what is in master. So whatever change, so you can see this is actually a feature that I released not too long ago where I updated the README file. So it's picking that from master and it's going to build that. So we can go back to the development pipeline to see what is happening. So we built the project, we've created a change set. Change set at the point of executing a change set is actually an AWS stack that you're creating at that point. So if you see here, we're actually creating a DevOps roadmap development stack. What is happening in there? All the stuff I showed you in the template. We're creating a bucket, we're creating a bucket policy, we're creating a CDN. There's also a Lambda that is going to like respond to the CDN itself, and there's also an origin access identity. These are all just details, some of the little details that you need for you to build something on CloudFront. So I'm just using more or less like the basic, very basic stuff from CloudFront to just get this up and running. So we'll just wait for this stack to be built. The stack is still building. Let's see. Let me refresh this page and see what happens. So yeah, the build is completed. So what our change set has been executed. It was created at one step. It has been executed in another step. And now there's the actual deployment is happening. So as with most pipeline, it just depends on your workflow. In this case, I'm actually executing the change set, and then the change set has created a CDN for me and a bucket, but there's nothing in the bucket. So the deployment itself is where I push my changes from the entire project. I'm going to be pushing everything I want to the bucket so that CloudFront can take that and show it to the end user. So if you check the deploys, sorry, let me bring that out. If you check the deploy script, very simple script also. So what it's doing here is that it's actually assuming a role. Like I said, the least privilege policy is very, very good. So we are not just doing any stuff. We're also assuming a role that would allow us to deploy. So what we are doing, we're assuming the role, we're getting the credentials for that role, and then we're running yarn install, we're running yarn generate. Actually, this is how you generate, this is how you deploy a Nox application. You run yarn install, you generate the files, and then there's a simple script that is recommended from the Nox documentation that is here. There's a GOP file. It does all this. So all I just needed to do was just give it the right configuration, and then it runs the deployment for me. So when you check that deploy script, it's really not doing much. It's just doing install, it's generating the files that I need, and then it's pushing it to S3 for CDN to pick. And then as usual, we are depending on Node.js 12, we're installing the packages, we are installing GOP and all the other stuff that we need for us to, deploy our application. And then this role that I'm assuming is actually part of the template. So I created it here and I've given it all it needs. It should be able to put stuff to the bucket, and it also should be able to interact with the CloudFront distribution. So you see that everything we're doing, we're using rules for them just to be sure that you're not giving unnecessary privileges to people or systems that use the pipeline. So let's see, it's still deploying. Let's give it some time. Let's see. So we can actually go to code build and go to details. So you know that it's not actually magic that is going on in there. It is actually doing what you sent it to do. So if you check code build, you can go into details. This is where it is provisioning the machine. This is when it is setting the node version to 12. It's installing yarn, installing GOP, doing all the install command that you sent it. After doing that, it went to assume this role, got all the, the access key ID, access key, the token. And then when it finished that, it actually created, it ran yarn generate, and created all this stuff for you, Favicon.ico, created all the JavaScript files that you need to deploy the application. And then once it's done, the pipeline is successful. So if you check this pipeline, it has succeeded. So this is master, I guess. Yeah, this is master. So let's go back to development. So I don't know, I think this was triggered twice, but the first one has actually succeeded. So what I'm just going to do, I'm just going to go to the stack that was created, which is this one, and check the output. And then I'll check CloudFront domain that was created for us. So if I check this, Awesome. So we have our app already running on AWS. So this is the app that we saw. So this app is the same thing as the one you saw in my local machine. So the beauty of it now is that you can send this URL. I'm sure everyone, if I send this URL to the chat, anyone can go to this URL, test it, you can collaborate with your developers. Oh, I pushed this change. Can you test it? Did I break anything? So people can test the change and see, is it working as it should? And then that is what will guarantee that the CI process is completed. And then when you merge, it starts a deployment on master branch. So, but the good thing about this stuff now is that the way it is, this particular URL, every time I push to development, so if as a developer, oh, you need to make this change, I can make the change and then push it to development. And then I'm sure that this is going to pick the change. And then when it picks this change, it's going to deploy it here. And then someone else can see the change. So that cycle continues. And then if you go to the master is, this is not master. Let's go to master. So master is still building. So like I told you about CI and I told you about CD. CI, continuous, I talked about continuous delivery and I talked about continuous deployment. So in this case, the way this is working, it is working in the form of continuous delivery. Why? Because this is a master change. Ideally, someone is supposed to see this, whatever comes out of this pipeline, the customer is supposed to see it. But here, there's a manual step. The manual step is ensuring that, oh, you are checking stuff, you are making sure, you are trying to be sure that things are the way they should. Remember, this approve release can be any step. It can be, maybe it could be, you can bring it down here. You can bring it, I'm just putting it here for you to just show that it is possible for you to have a manual process where someone will go in there and test it and be sure that, the pipeline can be approved. So if I review this, maybe, for example, this has deployed, maybe it has deployed somewhere else and I've tested it and it's working fine. I can approve it and say, oh, this pipeline is good to go. So because of this manual approval, this is a continuous delivery process because it doesn't just get to the end user direct. Someone has to, do some, there's a manual intervention, required. So it's also going to go through the release process. It's going to create a change set, do whatever it has to do. But again, the good thing about it is that the URL that you're going to be testing this is going to be different from the URL you are going to be testing the development branch for. So that it gives you the opportunity for developers to test separately from how the customers are going to test. And so we're just going to keep this and allow it to run. When it's done, we're just going to come back to it. So let me just, for the want of time, we'll just continue with the presentation. Can I do more? Absolutely, yeah. So what I showed you is very simple, very simple. You're pushing stuff to, very simple Nux.js application. But in most cases, you have like a front end, you have like a back end, you have so many things you are doing. In fact, you have an infrastructure that you can actually build pipelines to run your infrastructure. So you can be building infrastructure. You can have a team that's solely responsible for infrastructure. And you can also have pipelines for those infrastructure. So how am I going to guarantee that if I run this infrastructure, I'm going to get this? You can have a pipeline that verifies that before the end users use it. So you can do more. So for the ones I mentioned here, really, you can run stack tests. So for example, you can have a step that says, I want to validate that this stack is behaving as it should. Does it have the necessary, is the API functioning as expected? You can run tests on the database. So you can run tests on your infrastructure itself. So if you have a database, you might want to run some tests in the database. If you have some DynamoDB tables you want to interact with, you can do it here. You can do a whole test on your infrastructure before you let it go. So stack test is how you can do that. And then, with the code pipeline itself, you can do anything. One of it that I thought about is that you can actually deploy to multiple regions. So for example, in this case, I'm just deploying within the account, but I can say for disaster recovery, deploy to my US East account and deploy to my US West account. You can do all that with code pipeline. You can do anything, like you can integrate with Lambda function, you can integrate with step function, you can integrate with ECR, build Docker images. I mean, do anything in as much as is within the AWS ecosystem. And then you can also, for example, you can add a step that says, oh, master has been deployed. Can you give us a new release in GitHub? And then you can have a step that does that. Maybe call a Lambda function that says, relate with the GitHub API and create a new release. You can do all that from code pipeline. And then you can also even support multiple workflows. So in this case, remember, what I'm doing is that I'm creating a PR, but for everybody to test their PR, you have to measure changes to development. But you can also have like a continuous deployment for PR branches, such that when you open a PR, it creates a PR pipeline for you. And then when you push a change to that your PR, the pipeline picks it and tests it. And then for the lifetime of your PR, the pipeline is running, and you can test your own PR in isolation. Remember that the development branch, you might have multiple developers that are testing the development in the development branch. And sometimes it might become, oh, I want to use development branch. Oh, I want to use it. But you can say, okay, for your own PR, I want to create a pipeline for a PR. And then you can test your PR in isolation. And then when you are done, when you close the PR, you can have an automated process that also just deletes the pipeline and deletes all the resources that the pipeline is consuming. And then, like I said here, you can actually support custom workflows. So you can, integrate with your GitHub. Like I said, the release, creating a release in GitHub is like custom. You have to talk to GitHub, like do an actual API to GitHub. You can do a Bitbucket. You can integrate Jenkins with your builds, in your build process and all that. So you can do anything your workflow supports on AWS. The ideal pipeline, it depends, like I said. So people will say, oh, is this what we just built? Is it the ideal pipeline? No, it's not, because the ideal pipeline is just based on what you. In my own case, like why I built this pipeline, I'm just a solo developer. I know that a development branch and a master branch is enough for me to roll out my change. So I can build in development and test, and release to production in my master branch. So that works for me. But as your team gets bigger and the size of the teams also get bigger, you may decide, oh, what kind of pipelines are you going to be building? Are you going to be building pipelines per PR, or pipelines by development branch, or pipelines based on QA branch, development branch, and master branch? So depends on the team. And then the organization's policy around the release and deploy. Some organizations will say they want to release every 2 days, some say every 1 week. So all that has to be factored in before you have pipelines, before you decide how your pipeline should run. Because there are some automated pipelines that says, oh, you can only go and get code, after this period of time or this particular day. You can even have workflows that says, don't just pick code from GitHub. Rather, from GitHub, once there's a release on this day, trigger this pipeline. So you can, it just depends on your organization's policies around that. And then your team workflow. So how does your team work? And then your release cycle, how the team itself works and how, code is released, all that, you can put all that in play for you to decide how your pipeline should look. And then, like I said, the QA process around deployment and release. So if there's a QA branch that like your code needs to get to, for it to be matched to master, you can have that in place. So you can also have pipeline for that. And then you can say, oh, no. For every PR, someone needs to test it. I think I mentioned that before. So you can say for every PR, create your own pipeline, deploy your own change so that someone can test that your PR in isolation. And I think that's it. So before I go back, let me just check our master pipeline. I think it should still be building, or it should have been completed. So it's deploying. So let's just wait for it to finish deploying. But while it's at that, let me just go to the master. You see, there's a DevOps master stack, which is where it has created. You see, so that's why infrastructure as code is very nice. You don't have to do all this. So creating a new CDN or creating a new bucket, I don't have to do that. All I just need to do is, if I know that I need to have multiple ones in the same account, I can separate them with stage. Say, oh, this is master. Oh, this is production. Oh, this is development. And then you can have multiple of that. You can have multiple deployment in a particular account, and you can test them all in isolation. So let me just give you some time. But while that is happening, I think we can actually just click on the URL. And if you check very well, you see that this URL and this one is different. As you can see, at this moment, this URL is different from this URL. So this, for example, is going to, so if I have like let's say my application is hosted. So, like I said, this is simple pipeline, but if this stack itself was all encompassing, I could have like a certificate, I could have like a domain, and this will build, maybe this is going to be tied. I can connect this to like maybe, if this site
Kelvin,
was
we have like 3 minutes. Hello, Mr. Kelvin. So we have like 3 minutes more. We have like 3 minutes more.
Yes. I think I'm done already. So I just want to be sure that this is deployed. Yeah, it's deployed. It's deployed to master. So we were able to. So now, whenever any change is made to master, it goes here. Whenever any change is made to development, it goes to the other side. What else do I have? I think first I want to thank you again for the privilege to share. It was awesome connecting and sharing. And then you can connect with me. These are the fastest place you can get to me. Send me an email on kelvin.brainerd@gmail.com or connect with me on LinkedIn. I'm very active on LinkedIn. So thank you. Questions? I'm open to questions.
Oh, fantastic. Amazing. Thank you so much, Mr. Kelvin. You have taken us from a zero level, and I'm sure a whole lot of us, we are almost at the hero level. Thank you so much. I think at this point, we will actually accommodate questions because we have another speaker that is actually waiting for us. So we'll accommodate questions. If you have questions, please, can you simplify? So we can actually
get.
I
have a question.
We can actually get like 2 things.
Yeah, I have a question.
Mr. Charles.
Yeah.
Okay, please, let's have your question.
Okay, yeah. Good evening, everyone. My question goes thus. One, I mean, I'm a new person in DevOps, but I just bought my system not less than 2 weeks ago, trying to set it up. I want to learn DevOps, you know. I'm a fresher, I'm a beginner. So, but I want to ask to know if the specific program I should enroll on. That is my first question. Okay. The specific program I can be able to enroll on as a beginner in DevOps. I don't have any idea of this, but I want to roll into it. I've gotten everything done. So that is my first question. My second question is after this, can I get the video of this meeting? It's very, very important to me. So these are my questions.
Okay,
who's answering the question?
Yeah, do you have any other question?
No, I only have these 2 questions.
Yeah, hello, Mr. Ijeri. So you can have the floor.
Okay, thank you, Mr. Kelvin. Thank you, everybody. Yeah, I want to ask, Mr. As an AWS developer, why would you prefer GitHub rather than code commits for interacting with other developers? Why not use code commits, which is an inbuilt AWS interaction device?
Okay,
Okay.
thank you. So is that the last question? Do you have any other question? Okay. Okay, Mr. Kelvin, you can have the floor to answer the question.
Okay, so there's really no fast rule to that. I think for a lot of people that use GitHub is because they already have repos on GitHub. They already have teams collaborating on GitHub, you know. So they're already on GitHub. They're already very established. They have a lot of projects on GitHub already. So they just stay with GitHub. But for someone like me, maybe like I want to create something new, I can decide to create it on code commit. But I feel a lot of them that use GitHub is just because they're already established, like they're already on GitHub. Like, so moving it to code commit, there's really no point. I mean, you can get the same value. It's just that code commit again is a bit, most of the, for example, like talking to code pipeline, you still have to do a lot of the niche stuff with AWS. You have to, you know, send stuff to like listen to events, you know. So everything is all AWS, but there's still some people that they have other tools they're already using that's outside of AWS and they just want to integrate it to AWS. So if I'm using Jenkins already, I don't have to throw away my Jenkins. I said there's need. If I'm already using Bitbucket, there's no point throwing it. So there's no one is better than the other. It's just, it depends on your team, your organization already. The organization is already enjoying GitHub and they remain there. I mean, there's no point really changing to code. But as a developer, if I want to just enjoy the whole AWS, you know, ecosystem, I can stay on code commit, create my repos in there, do whatever I want to do, you know, enjoy life in there. But for big organizations, they're already on GitHub and they're doing well there. So maybe I think that's just why. There's no one, like one is better than the other.
Okay, yeah, I think we have another question here. I'm going to answer the first question here. Then we have another question that is Linux important for DevOps in DevOps?
So I'll allow the second speaker to speak more about DevOps. So there are different aspects of DevOps. I like to call myself a cloud engineer because I moved from software engineering into cloud engineering, and I enjoy that part. So you see me building Lambda functions, step functions, you know. I'm more like the DevOps guy who likes to code, you know. But there's also another DevOps guy who is just like, you know, is more related to sysops. You have to do a lot of, you know, Linux administration and all that. So I feel those are the two sides of DevOps. You can fall in either of the two, but I think Linux knowledge is important. But there are some places that you might not even be doing so much in Linux, because most of these applications you are building, they are just building stuff in the cloud, and all that you may not require to do a lot of like core Linux development. But like I said, the second speaker will do more justice to DevOps. Like, there are so many aspects. DevOps itself is very huge. Like, so you can be doing cloud engineering, which I like to call myself, because I'm more of the coding person of DevOps. I'm not like the hacker who's in Linux trying to configure stuff. No, I'm not. But I'm sure the second speaker is going to do more justice to that. So, but I don't think you need. I don't think Linux is very good. Like, yeah, your Linux skill is very, very good, but I don't think it's like, if you don't know it, you can't do. I've been doing a lot of DevOps without much doing, like going very, very in depth into Linux. So.
Okay. Thank you so much, Mr. Kelvin. I think some of the questions that have been asked, by the time the second speaker speak, we are going to get a whole lot of details about what DevOps is, and some of the answers to some of the questions that we have asked so far. I really appreciate your time, Mr. Kelvin. And without wasting much of our time, I think the time is fast spent. We will move into the next discussion. Actually, it's ought to be the first discussion. We are supposed to have a roadmap into DevOps before having the workshop on CICD. But I think what we actually did in this part is actually to go deep dive into the workshop, learning about CICD, and now we actually want to know it's some theoretical parts and some of the things that we need to understand before we can actually learn CICD. So without wasting much of our time, I want to invite Mr. Adebayo Adeshegun to come on board. I'm going to transfer the invisible microphone to him to take us through roadmap to DevOps. That is where he's going to be delving into all the things we need to know and some of those things we need to have in place when we are doing DevOps. Mr. Adebayo Adeshegun is a principal officer of Diary.io, and Diary.io is also a learning platform. I want him to introduce himself better. Thank you so much, Mr. Adebayo.
Hi, everyone. Good evening. First, I want to start with Emeka. Thank you, Kelvin. Thank you very much for the wonderful session. I enjoyed the CICD pipeline, and I must say I've learned one or two things. That's just it. Thank you very much. And secondly, I want to apologize for showing it. I was a little bit under the weather, having cold, so I stepped up actually. So sorry for that. But now I'm very, very much with you now for the session. So then another thing I would like to also correct before I start. I'm actually feeling the shoe of my boss here, the principal DevOps at Diary.io, which is Diary himself. My own name is Adebayo Shegun, and I'm the senior DevOps mentor at Diary.io. Okay, so that's that about the introduction. I'm going to share my screen now to begin this session. Okay, please, can you hear me clearly and can you see me clearly?
Yes,
okay.
We can see you and we can hear you clearly.
Thank you very much. So I'm sharing my screen. Okay, I'm going to minimize this. Okay. Let me take this to the particular place. Let me bring this one down here. So let me refresh the page. Okay, so I will just close this one so that we can focus on what we have. So I'm going to be talking about roadmap to DevOps. Kelvin at the start of the lecture has taken us around what a CI/CD pipeline is, a full CI/CD pipeline. He showed us how you take a code from your repository, you take it through a pipeline, then you either deploy it to your dev environment or to your prod environment, as the case may be. It showed us the things that are involved in a pipeline, the build phase, the test phase. Yeah, it showed us that mostly in the AWS environment. But you also mentioned the fact that we can also use other third-party tools, which we used one of them, which was GitHub. But what I want to do in this particular session is talk about what DevOps is itself. What are the concepts or what are the philosophies behind DevOps? What are the tools around DevOps itself? As a DevOps engineer, am I limited to AWS resources only? As a DevOps engineer, what am I to do? What are my daily activities? Right. So these are the things I want to talk about right now in this second session. So as I said earlier, I am stepping into the shoe of Gary. Is a certified Kubernetes administrator, and he has a lot of certifications around DevOps himself. You can reach him on LinkedIn in this particular. I think his name was LinkedIn.io, so you can reach him on this LinkedIn page. He's a certified Kubernetes administrator, AWS certified DevOps engineer, solutions architect. He has wide experience in DevOps and site reliability and cloud engineering. So he has got a quite experience, and I personally trained under him. But I myself, my name is Olufunmilayo, and I'm a senior DevOps mentor at Sky.io. So Sky.io is a platform where we train DevOps engineers. Our platform, our approach is what we call the PBL approach, the project-based learning approach. So when you join the platform, you get to watch videos, then you get to get your hands dirty. So for instance, like like this demo that Kelvin gave to us, we have one of those demos on the project now, where you have to implement a full CI/CD pipeline, writing the code yourself, put it to the pipeline, then deploying to different environments. So that's what we do at Sky.io. Okay. So if you want to know more about that, you can just go to www.gary.io or you ask me in the chat box and I'll give you the link. Right. So I'm going straight into the session itself. But before I begin, Kelvin, please, how many minutes do I have so I can work with time?
Okay, you have minutes. You have 20 minutes.
20 minutes. Okay, so
by 5:40, we should round this off.
Yeah, I really want to work with time. So the question is, what is DevOps? As defined by AWS, which is Amazon Web Services. DevOps combines cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Now, these are high lingual terms. In a simple terms, what is DevOps? In time past, before we add the word DevOps, we have two set of teams that brings applications to life for us. Imagine your Facebook is an application running in a particular server, right? Your WhatsApp is actually an application living in a particular server somewhere in the world. Now, you as a user, all you want to do is go to Facebook, like a picture, store your pictures, right? But at the back, there are two set of people or several set of teams making this to happen. The two out of these teams are, one of them is the operation teams, and one of them is developer teams. Now, the developer teams are the set of people that write the codes. They put all the functions together, they put all the logics together, and they say, oh, operations, you are ready to make this go live, and they push this code into the servers. Then you, as an end user, you go to www.facebook.com and you start liking pictures, you start uploading pictures, start chatting to your loved ones. Now, there are a lot of things that need to make this happen. So when the developers are finish writing the codes, at the first release, everything is okay, everything looks good. But what happens when you want to introduce a new change? That is where the problem comes in. So the operation guys are like, no, you can't make a new change because it's going to break the system. Some of them are working towards the same goal, but they always are loggerheads because the operation guys want to keep the servers up and running. They want to make sure that nothing is breaking out the servers. But developers, they want to bring in more features. They want to allow you to upload your pictures, paint your pictures, add filters. Those are features, and they want to develop and push in more changes into these servers at all the times. Now, because two of them work in silos, they work in different aspects, then this makes the production but very, very tight. So that's where DevOps comes in. So the developers, they work on their own. After writing the code, they throw it over to the operation guys. Operation test it and say, oh no, this code is not okay. They push it up to the developers. So there was a back and forth between these guys. Now that's where DevOps now come in. Now, what DevOps tries to do is that DevOps now tries to bring the developers, the operations, the quality guys, the stakeholders, bring all of them together into one thing. So everybody works together as one big family. So I put in simple terms, it brings collaboration between the developers, the quality teams, the operations, the stakeholders to deliver a product to consumer in a secure, repeatable, and automated manner. So what that philosophy brings is that as developer is writing the codes, is pushing it into a pipeline, a series of tests are going on, and why that test is complete or why that test is passed, just like as the CICD Kelvin has showed us, if that test passed in CICD pipeline, then it deploys into production. That was the main idea behind DevOps. So because these app producers want to release new features every day, they want to be ahead of their competitors. They want to make sure that, oh, they are releasing new features that are coming, just like Facebook and Instagram before they merge together. You know, Facebook want to bring more features, Instagram want to bring more features. Then this needs to happen at a very faster pace. So DevOps help us to bring these people together. They don't have to work in silos anymore. They have to work together as one big team. Okay, now that's DevOps as a philosophy. Now, what is DevOps as a profession itself? So a DevOps engineer is a person that uses tools and methodologies to achieve the goal of DevOps. So the goal of DevOps is to make sure that our code gets to production faster. That is the goal of DevOps, right? Now, not just code, quality code, right? Not just anyhow code, not just broken code, not just code filled with bugs, you know, not just codes that won't work, right? Quality codes, get into production faster. So DevOps engineer now is a person that uses tools and methodologies to achieve the goals of DevOps. DevOps engineers work with developers, product owners, the quality assurance team, the business team in order to work to deliver a quality code, right? Cool. So now before I move to becoming a DevOps, the next slide, which is becoming a DevOps engineer, I would like to talk about the CI/CD pipeline that Kelvin showed to us. So in that CI/CD pipeline, if you notice, in the first phase, you have a build, right? In the second phase, we have a test. Can you still hear me? I hope I'm not talking to myself.
Oh, yeah, we can hear you.
Yeah. Okay, so in the first phase, you have a build. In the second phase, you have a test.
Yes, but we can hear you, but your voice is low.
My voice is low? Hello?
Yeah, there's a kind of there's a type of it's kind of dim, you know, it's not as clear as Kelvin was, but we can hear you.
Okay.
But, yeah.
Hold on, let me switch my headset, okay?
Let me know if it's better. Is it better? Hello?
Yes,
this is much better. We can hear you.
Yes,
much,
better than the
much better. Oh, okay, thank you very much. So, were you hearing everything I've been saying before? Do I need to recap? Okay, I assume you can hear me, so I'll just go.
Yeah,
So I
we
was
heard
saying,
you.
okay, so I was saying that before I move to becoming a DevOps engineer, I would like to talk about the CI/CD pipeline that Kelvin showed to us. I said in the CI/CD pipeline, we had the build phase, we had the test phase, then it deployed into the respective environment we had. So initially, before we have a pipeline, before what happens is that the developers write the code. If you remember, Kelvin wrote the code and tested it on his local host before he moved into a pipeline. So that's what actually happens initially before. The developers write the code, they package it, and they just take it and dump it into the operations guides with a set of instructions of how to install it. So at the end, the operations guys have to take the code, follow the instructions, then install it on the server, and then we have access to it. Then while before installing it, the security guys might have done their checks and say, oh, check for bugs, check for vulnerabilities, and do a lot of testing by themselves. And that takes a lot of months or a lot of weeks, probably. So while they are checking, if they find bugs or they find vulnerabilities, they take the code and return it back to the developer devs that, oh, we found a bug in your code, we found a vulnerability in your code. Then the developer has to write again, develop the code again, and push to the security guys again. So this continues back and forth, and before you know, time has gone. If the code eventually passes the security checks that are done by the security guys, then they forward it to the operation guys, which then follow the instructions and then install the applications on the server for end users to have access it. But when DevOps came in, we don't have that sort of silos anymore. So we have we now have an environment such that as developer is writing the code and pushing its commits or our commits into the GitHub repository, as a case may be the GitLab, then the pipeline kicks off, right, and performs some set of actions, which are basically build, test, and deploy. That is the whole summary of DevOps, right? So now I want to talk about becoming a DevOps engineer. What are the things you know? What are the tools that are involved? Yeah, what are these philosophies? What are these concepts that we need to talk about? So I'm going to go to the next slide. So becoming a DevOps engineer, this guy is taking so much screen. I think this is better. So as I said earlier, I said DevOps is not a role. Rather, it is a philosophy that can be applied to different spaces in the IT industry. It can be applied to machine learning, it can be applied to fintech, AI, and so many more. I don't know if you have heard about the term FinOps, MLOps, AIOps, and so on and so forth. So DevOps itself is not just it's not just a role per se like that. It's an idea. It's a philosophy that, okay, come, we don't want to work in isolation anymore. Let everyone work together. Let all the stakeholders come together, explain their goals, put it in the pipeline, and allow a little bit of iteration so that as we are pushing this in the pipeline and we found a bug, at an early stage, the developer can know that, oh, there's a bug in my code, I need to fix this. As the developer is pushing, I think of recent, GitHub introduced a feature called advanced security action, something like that. For instance, if you put an access key, AWS access key or AWS secret key into your repository and try to push, if you turn on that feature, it tells you that no, you can't push this commit because you have a password or a secret stored inside your commit. Now that's an advantage of DevOps. In the previous stage, you have pushed the commit. It is when the code review is being done or when the security guys are taking check, that is when they notice the code or the vulnerabilities. So one advantage of DevOps is that at an early stage, you notice the vulnerabilities, you notice the code bugs, and the developers immediately can be aware of it, right? And they make the correct changes in order to fix their bug or vulnerability. So it's not actually a role per se, it's just an idea. And you can apply it to fintech, which involve FinOps, so that as they are building their applications, they are doing their things, everything works faster for the team, right? So I say becoming a DevOps engineer now, don't forget that I talked about DevOps as a role, and I talked about DevOps as a profession, right? So I need you to understand that. So becoming a DevOps engineer requires that you must first understand the concept. You need to understand this concept. As a DevOps engineer, you must be good in communication because you're going to interact with different teams. You are the go-to guy in the team. So you're going to interact with different people. You must be good in communications. You must be able to learn fast, and you must be familiar with good number of technology. So you must first understand the concept of CICD, the concept of automation, the concept of speed. You must first understand this concept. Now, when you understand this concept and what CICD is, what automation is, then you cannot go ahead and learn the tools that helps you achieve this concept that you have learned about. There are different concepts. We have infrastructure as code, we have Jenkins as code, we have pipeline as code, sorry. We have containerizations, we have container orchestrations, right? We also have source code management also. So there are a lot of concepts, a lot of philosophy around it. So you need to learn these things, understand how they work. Then you cannot go ahead and learn the tools that helps you achieve this concept and then get hands-on experience. So learning DevOps requires that you should have an hands-on experience. Very important. You must have got in your hands state, you must have implemented 1 or 2 projects to ensure that, okay, yes, I have a little experience in this in this area. So I'm going to go to the tools next. I'm trying to work with my time. So there are different tools. Agility is just ensuring that your code is reliable and all the teams are working together. Agility was a term that was being coined by the Scrum guys, the Scrum master. So in the DevOps teams, we have a Scrum master. The Scrum master is the person that ensures that, in a simple terms, as I can put it, the Scrum master is someone that ensures that everyone is doing their job. So it could be a female, it could be a male. So let's assume she's a female. She's one that assigns tickets to everybody that, okay, Kelvin, you're doing this. Okay, Sherry, you're doing this. Jeremy, you're doing this. And after a sprint, I don't know, they call you together, okay, what is the update on this ticket? So that we can deliver the products at the set time. So that's what we call agility. Now, continuous integration. I think I can remember that Kelvin talked about so much about continuous integration and continuous delivery. So I will not dive much about that again. So continuous integration is making sure that the code is being matched at every commit, and continuous delivery is ensuring that we have the applications are being deployed. That's like the automation of continuous deployment. Continuous deployment is like you deploying into a server at every point in time, but you still need a manual approach for continuous delivery, so automation of all those aspects. Then in DevOps also too, automation is key. Automation is key. Automation is key. Automating everything as you can do, as you can. You have to try as much as possible to automate. Anything you find that you are doing every day, you must think automation. As a DevOps engineer, you must think automation. Then security also too, because you want to be fast, you want to deploy faster, you want to get production you want to get code into production faster than your competitors. That does not mean you put a bad code into the production server. Security must be involved. At the first commit, even at the pull request, I designed a pipeline sometimes last month, and at the first line of defense was the pull request. Once that the way the pipeline works was that once the developer makes a pull request, the first thing that takes place is unit testing. So if your pull request is not even passing the unit test, of course, the pull request is not getting matched. Even before code review, right? If your unit test is not passing a certain code coverage, the pull request pipeline is going to fail. So that's the first set of security that will be there. Once, if probably your pull request passes, right, gets merged into the development, the code review is done. Then after that, I want to do SAT, which is security scanning, also to which is static code analysis, which we know as SCA. There are a number of tools that help us with that. I'm much more familiar with SonarQube. I'm familiar with Snake and Coverity. Those are security tools that helps us do some security analysis. It checks for vulnerabilities. It checks for code coverage, like SonarQube. It also checks for it checks for bugs also too. It checks for code depth. Yeah, also too. So these are that part of that security that you must also consider. Right now, I'm going to move to DevOps tools. Right, so DevOps tools that we need to consider are in ranges. We have the cloud. In the cloud, we have the cloud aspect. We have the continuous integration. We have the ISC. When I say ISC, I'm talking about infrastructure as code and configuration management. Excuse me. We have code analysis, containers and orchestrations, version control, observability, and artifact management. So there's a lot going on in the DevOps space, a lot, and it's very, very wide. And one thing I would say is that a lot of tools are available for you to learn, and new ones keep coming out every day. But do not be overwhelmed. You don't have to be overwhelmed. You have to take it one step at a time. One thing I've noticed with some few people I've had encounter with in the DevOps space is that a lot of people lack patience. They want to consume everything at a time. It's not going to work, trust me. It's not going to work. You have to take this one after the other. Sometimes I gave myself a roadmap that, okay, these are the tools I want to learn for this month. And truthfully speaking, sometimes I don't get to fulfill my list. It could be one technology I learned that month, but I'm fine because I understood the concept, I understood the technology. So DevOps has a lot of technologies and more are coming out every day. But you have to learn what you need to learn and ensure that you are comfortable with it, you are convenient with it, right? It is good to have an idea of what it does, but you learning it, you have to take it step at a time. So in the cloud aspect, we have the Amazon Web Services, we have the Azure, we have the Google Cloud Platform, the DataOcean, and Linode. What these people do is that they try to provide virtual servers for us, right? So when I hear the word cloud, when I started Devops or IT generally, when I heard the word cloud, I used to think cloud somewhere in the sky, somewhere in the air. How come you are storing, physical machines in the cloud? So it got me crazy then. But later on, I found out that cloud is just some set of servers existing somewhere in the world, right? So we have Amazon services that have millions of servers. So all you have to do is create your AWS account or create your Azure account, your GCP account, or whatever account you want to create, log into their platforms and create the number of servers you want, right? So these are the guys we have in the cloud aspect. I, for a person, I use Amazon Web Services mostly. I'm not familiar with DataOcean and Linode very well, but that doesn't mean you can use it because most of them are actually familiar. Like when I mean familiar, like they are kind of similar because they try to offer the same services, just like load balancers, databases, VMs. They might have different naming conventions and different email that comes with it. The underlying concept is still the same thing. They want to offer you load balancers. They want to offer you instances like VMs. They want to offer you databases. They want to offer you data warehouses. They want to offer you API gateways, Lambda functions, different things. They want to offer you CloudWatch. So it's just different things, but I'm much more familiar with Amazon Web Services. And I've used a little bit of GCP. I've not really used any Azure resources before, basically. And then for continuous integration, we have GitLab CI, we have Jenkins, we have GitHub Actions, we have Circle CI, we have Azure pipelines. So there's no fast route, there's no hard route to it. It depends on what the team you joined, right, and using, then you can then choose the one to use. But if you're starting a new project, you need to decide what you want and what you want to achieve. I mean, what you want and the pros and cons of what you want. So that helps you choose a tool. You can't just say, oh, no, I want to use GitLab CI. Oh, no, I want to use Jenkins. So you have to sit down, check what you want. You need to highlight your own requirements. Then look at the tools that fits into this. There are different requirements that you have to go into, right? So that's for continuous integration. So I see the CI server as the master, like how would I put it now, as a controller, right? I'm sure that your own engineers are familiar with the last month. You see them standing in the middle of a roundabout or something, and they say you go, you stop, you come, stuff like that. That's how the CI server is. It coordinates every activity of your entire pipeline. It's like the center, right? So it coordinates every activity. It tells this to deploy, it tells this to wait, it tells this to destroy. That is basically what the CI server is saying. We have infrastructure as code and configuration management. So infrastructure as code, right now, I think as of the last 2 years, this concept also too was gaining fame in the DevOps industry, trying to treat your infrastructure as code. So imagine that your servers, that your VMs, your EC2 instance, all the things you need to run your applications, you're not writing a code to actually create them, something like that. So for instance, now, I think I might just show you quick. I can just show you a Terraform code. Imagine I want to create just some EC2 instance to deploy a web server, something like that. So look at this. For example, look at this now. This is me writing the Terraform code to deploy an AWS load balancers, something like that. So that is what infrastructure as code is. You writing codes to deploy your resources. In the time past, what sysops do or system administrators, what they do is that they just go into the SSH into the server, right, and just do the configuration of what to do with the servers they need to do and stuff like that. But now you can actually automate that aspect, put your infrastructure into code, put in a source code management, so that you can then version it also too. And from there, it's going to make it easy to coordinate your infrastructure. So for instance, now let me use AWS as an example. I create 5 EC2 instances in Ohio, right? And I've given it all the configuration it needs. So imagine that I want to create another 5 instances also to be non-Virginia. That means I have to probably change region. Excuse me. I have to probably change region. Now start creating those resources manually again from the console. But since I already have those 5 instances created in Terraform, like all I have to do is go to Terraform code and change the region, and that's it. So I'm using Terraform as an example. There are other infrastructure as code also that are very, very interesting. We have Salt, we have CloudFormation. CloudFormation is native to AWS because it's not cloud agnostic, unlike Terraform that is cloud agnostic. Salt is cloud agnostic also too. Then Ansible also too. Ansible, I personally see Ansible power more in configuration management. So let's say, for instance, now you have created the EC2 instance, right? That's the infrastructure. Now you need to configure it. An example of a configuration is installing an Apache server, right? Starting the Apache server, deploying a simple web server. That's an example of a configuration. So Ansible can do that for you also too. Okay, and you can combine these two together. Most of the times I've combined Terraform and Ansible together and put the two of them in a GitLab here. So I've seen most of these combinations like that. Code analysis, SonarQube, Coverity, Snake, as I said earlier. So SonarQube, I'm much more familiar with SonarQube, but with SonarQube to quite a number of projects. So we use SonarQube to check for code coverage, right? So we said a particular percent that okay, if your code coverage does not reach 99.9%, the code will fail, just an example. So we use SonarQube for that. We check vulnerability, we check code details. So that's what SonarQube does for you. Coverity and Snake also too are very nice tools. But I've said earlier, you have to write out your requirement before you know the tools you need to choose. Containers and container orchestration. So this in this aspect is another new technology also too, or not really new technology, but another interesting concepts in DevOps itself. So initially, you develop to write the code that, oh, the code is working on a local machine. I deployed, it's working fine. It's going to show you a demo. And the system engineers try to deploy it on the system, like, no, this is not working on my system. And that could be because of dependencies. So let's say, and the developer's machines and is using Python 3, and the system guy is using Python 2.9, and that could cause the installation to feel like, no, take your code, it's not working, it's not working. So to avoid that, the concept of
3 minutes more.
3 minutes more, okay. Concept of containerization comes in. So containerization helps you package it into the Docker file, then you can now deploy it. So for containers and containers orchestration, we have Docker, we have Kubernetes, Podman, lineage, and so on and so forth. Then for version control, GitHub, Bitbucket, GitLab, AWS Code Commit. For observability, this is for monitoring basically. We have the Datadog, we have the ELK stack, the CloudWatch, the New Relic. Then for artifact management, artifacts are the result of a build. So when you make a build, for instance, when Kelvin built his Nux.js at that time, there's a result like a build. The result of the build will call artifact. You can store it in JFrog, Nexus, Docker, or as case may be. So my last slide before I'm being taken offline. So DevOps, how do we begin? How do we start? Right. So this is not actually written on stone. You know, it can change, but this is one of the simplest approach I have seen to be working. Right. So the first thing I want to learn a programming language. Mostly I recommend Python, easy to learn. And apart from that, you as a DevOps engineer, you're going to need Python later on, mostly for automation. So that's why I suggest Python, but it's not a hard fast tool, but at the side, you can begin to learn that. Now, when you have the knowledge in one programming language or the other, there's this level of exposure you have than someone that is totally new to the environment. Now, please don't get me wrong, because you're totally new to IT does not mean you can't learn DevOps. Even though you have zero knowledge about IT, you can learn DevOps. You just have to start from somewhere. Okay, so I do recommend that you learn in programming language, this mostly Python. Then the next thing is learn different OS concepts, Linux, Windows, understand the difference about these two operating systems. Right, in the Linux, you now have different Linux distributions, but try to understand the basic concept about these two operating systems. The Linux administration. So why I say Linux administration is that most of the servers they're going to be working with, they're going to be Linux. There are some companies that do have Windows also too, right? But for you to also have, shall I say, let me just use the word reputation outside, for you to be at least be familiar with almost everyone when you see job applications, Linux administrations. And that also leads us to Bash, scripting also too. So you need to be familiar with Linux administration. Most of the instances in AWS are Linux, right? They also have Windows instances. But I personally, as a person, in my little experience and my little journey, I've seen little of Windows and I've seen more of Linux. Okay, so you need to learn about the concept of web servers and proxies. Yeah, I'm almost done. Good balancers, version control, continuous integration, continuous delivery, the cloud, configuration management, infrastructure as code. I have actually put them in order. Yeah, I've actually put them in order. You have to learn them in order because if you want to learn infrastructure as code, you must know what configuration management is. Learn containers orchestrations, the monitoring, logging. I wish there was much time I would have put this down step by step so you can have an idea of what they need. But I do hope I've been able to share some of the knowledge with you, and that takes it to my life side. And thank you for listening. Thank you very much. Yeah, Jamie, over to you.
Oh, great. Thank you so much, Mr. Ayo. I think this is a great eye-opener into DevOps. And with what you have said so far, in fact, someone is already saying this. I love this. You have actually you have given us the pipeline of how DevOps operates. And you have actually shared with us some of the tools that we need to learn. So I think the first questionnaire that asked that I just want to start my DevOps journey. So the first thing you need to do is that you need to understand the tools that you need to learn. So like Mr. Shegun Adebayo has said, he said that you need to learn a programming language first, then you now move ahead to learn so many other things. So let's try as much as possible to go there. So before we go ahead, I have one or two questions here that I would love to share with the audience. So by the time I share this question, let me share my screen. So by the time I share this question, if you have answer to it, just put it on the group chat. I'm quite sure that we have some freebies. So the first person to answer each question.
Sorry, do you have any question? Do you have any question for me?
We are still going to get question after this. This is just more like an interlude.
Okay.
Okay, so the first question is okay. So this is the first question. Which AWS resources will you need to set up your CICD? Do you have an answer? Do you have an answer? Oh, you have somebody, Code Pipeline. It's actually Code Pipeline. That's great. So we have Etim Udo. Etim Udo will reach out to you. Okay, so let's go to the next one. Okay, the CICD code is written in what language? I mean, the code that you are going to guide so that will tell you to build for more stage. Your pipeline code is written in what language? Oh, great. We have an answer already. So it actually shows that we are all following along. So we pick we'll pick those that actually want the prize, and we'll get in touch with you, and you get some freebies from courtesy of AWS Nigeria and AWS itself. So let's quickly go to the next thing. Questions. If you have questions for Mr. Adebayo Shegun, so let's quickly get that. Okay, someone has a question here. We have, he said, after you have set up your CICD and everything is automated, what other things do you need to do as a DevOps engineer? Yeah, your day-to-day activity. So after you have done the first CICD, what else do you do?
As a DevOps engineer, you solve problems. That's what I want to tell you. You know, things break a lot in the cloud. There's always one problem to solve or the other. Things break a lot. Things are going to break, and you must be ready to. So the first thing or the first skill I built was troubleshooting. That was the first skill I built. So, and where did I learn my troubleshooting? Google. I don't have any book to recommend to you. The book I can recommend is Google. You must know how to Google. You must know how, because it's not just about typing, how do I build ice cream? No, you must know how to use your keyword in the right way, so that you can get the right answer. So, which we all know is Stack Overflow. So, as a DevOps engineer, the first thing, most of the things you do every day is troubleshooting when there is errors, right? So that's most of the do as a DevOps engineer, troubleshooting. Then another thing again you do as a DevOps engineer is that you architect solutions. So for instance, now the thing comes, oh, we don't want to use this again. We want something like this. Give us an example of what we need to do. So they can tell you that they want a cake in the cloud. They can tell you that they want to cook something without using fire. So it is now your job as a DevOps engineer to brainstorm and bring out the right solutions. So you must think about cost. You must think about security. And most of the time, the people you are dealing with does not understand the jargon you are saying. So you must be able to explain the concept with them. So that's two things I'll say now. Another thing again, as DevOps engineer again, although not all DevOps engineer likes this, documentation is also another thing you need to put in place. So if you have finished a project or you are done with the pipeline, everything, you need to put it into documentation. So that if you are leaving the company and another DevOps engineer comes in, if you have 1 million lines of script, by the engineer looking at the change log file or the README file, the engineer understands what you are doing in less than 30 minutes. So a lot of other things to come in place. But most of the 30 things I say, number one is troubleshooting day to day, solving one error or the other because of one break. Secondly is rewriting documentations, and third is also you architecting, providing solutions. Anybody can call you from anything that, oh, you have this is down. You're the go-to person in the team. Everyone wants to talk to you and you must help them solve their problem. Okay, I hope I've answered the question correctly.
Yes, that's a very good answer. I think there's another question here. You were asked that what's the difference between a cloud engineer, a DevOps engineer, and a cloud engineer?
Very good. So there's a tiny difference between them, right? But DevOps engineer are particular about the code getting to production, right? Creating the infrastructures and everything. That's what they are particular about. But I think the cloud engineer are more the cloud aspect. When I say cloud aspect, creating instances in the cloud or creating resources in the cloud. Make sure that one resource is talking to another resources. That is what the cloud engineer does basically. So I can even share my screen and we can as well go check it out even in Google right now. As I said earlier, Google is always my friend and I'm not always shy to check Google for my answers. Let me share my screen. But I do think that there's a slight difference between these two people. You can see my screen here. Can do difference. Yeah, this is another site I like to read also, to Geek for Kids. There are some sites that I recommend, like Digital Oceans and Stack Overflow. I trust those people and I do go through their this thing every day. Yeah, so a cloud engineer, I look at it. A cloud engineer is mainly responsible for various technical responsibilities under cloud computing. You see, a DevOps engineer is mainly responsible for various development and operation of software and applications. So I think it's more related to what I've said just now. So I can share this link in the channel if you want. So please don't, anything you can think of is in the cloud, is in Google. Just all you have to do is search for it. All you have to do is search for it. Anything you can think of, like, oh, I don't know about this thing. If I want to learn new technology today, Google is the first place for me to go to. Right. So I'm dropping this in the chat. Right. So yeah. I hope I've answered the questions. Yeah, Ibrahim is raising up his hand.
Okay, Mr. Ibrahim, please go ahead, your question. I think that will be the last question for this event.
Okay.
Are you there, Ibrahim? Ibrahim, are you there? Please, we can hear you. Go ahead, ask your question.
Okay. I think probably he's having mic issues.
Okay, I guess you can type it in the chat. If we can't hear you, you can type it in the chat so that we can go ahead to
excuse me.
Hello.
Okay, why? Okay, hello.
Okay, I think while we are waiting for him, let's just go ahead to some of the announcements that we actually have for us. Yeah, it has been a very wonderful day, and we had a very wonderful time with people like Kelvin, like Adebayo, and even Mr. Kim has actually shared a lot with us. So from AWS User Group, there are a lot of things that we also always wanted to know. The first thing, let me share my screen. We have some information for us. So the first information that we have for us is that we have AWS Associate Challenge that is ongoing. The AWS Associate Challenge is organized by AWS. It's a challenge for those of us that we are just coming up in certification line. So if you join the challenge, you'll be given opportunity to a free practice exam for one of either solution architects or developer associates, and we have system ops as well. Then they also give you some other materials that would make you to go ahead in that line. So, and the deadline for the registration is on the 30th of April, 30th of this month. So we are going to share some of these links on our group chats as well. So we have AWS Shipbuild. AWS Shipbuild is one of the programs of AWS, and currently they have two programs running. We have the cloud practitioner and the solution architect. So if you have any female around that is joining this cloud journey, so part of the things that they would have opportunity ahead of in the AWS Shipbuild is that if you join the cloud practitioner program or the solution architect, they are going to take them through live sessions on some of the solutions, what the exam is all about, and what AWS is all about for that particular exam that they're about to write. And at the end of the day, they will give them a free voucher, a free exam voucher to write the exam. So for the cloud practitioner, the exam actually costs $100. So if you are joining that program, you get a $100 free exam voucher, and for the solution architect, it's actually costing $150. So you need to, if you have any female around you that is in the cloud environment, you need to ask them, you need to encourage them to join. And if you have somebody that is still thinking that they want to join the cloud, I think this is a very great opportunity for the females around us. And for iLook, that is AWS Nigeria User Group. We are going to have events all around the year. This is one of our events. In January, we had a physical event. Very soon, we'll be having some other physical events and other virtual events. Our events ranges from different parts, from starters. I know that there are some of the people that joined this event and they said, oh, we are just starting up with AWS. I'm about to get my cloud practitioner. But here we are in a technical session whereby some of the things we are actually being exposed to are things that we know, yeah, we are going to do this in the future. But now I don't understand. Yeah, there are some other events that we actually do that is going to be focused on starters, and we are going to do things that will be more familiar with you. Then also we are going to also have some other technical sections like this, and we also encourage you, if you think that there's an aspect in the cloud environment, or there are things that you want us to discuss or you want us to talk about in our upcoming meetups, please kindly reach out to us. We are also going to consider. It is not about Mr. Akin, it's not about me, it's not about anyone, it's about every one of us. In Nigeria, we want all of us to join the user group and also move AWS, not just moving AWS to the data, but move the software, the cloud environment in Nigeria and ourselves as an individual to the next stage of where we ought to be. I really appreciate every one of us. Let me stop sharing here and call on Mr. King if he has anything to dish out.
I don't really have anything, so I just want to say thank you, everyone. Thank you for the speaker. This is amazing presentation. You guys are awesome. You know, I'm sure everybody really enjoyed every piece of the presentation. So thank you so much for your time. Really appreciate it, and thank you for everything. So for those people that are asking for recording, we're going to share it on our YouTube and the speakers slide and information, so that you guys can have it. So thank you very much, Jamie, for organizing this, and thank you everyone for joining. Take care, guys.
Okay, thank you so much. I really appreciate Mr. Kelvin. I know I actually chatted Mr. Kelvin up on LinkedIn, and he agreed to do this, and he did it well. And I also want to appreciate Mr. Dare through Mr. Adebayo Shegun. I know Mr. Adebayo Shegun also on LinkedIn, and I also met Mr. Dare.io also on LinkedIn. So I think LinkedIn is also a very good place for us to connect with each other. I really appreciate.
Okay, thank you. I'll be with you. Thank you.
Yeah, for every one of us, I am really glad that we are here, and I hope that what we have learned today will take it a step further by implementing CICD in our workplace, by actually making an attempt to learn some other new things in AWS, by actually bringing out the DevOps that are actually that is resilient in each and every one of us. I hope to see every one of us in our next AWS event. I would also like to see you make some comments on the chat box. Give us some suggestion on what you think we should actually do next. And I want to wish every one of us a very wonderful day ahead. And I want to till we see us next time, probably next month or next month, you actually reach out to us on this. I want to say have a wonderful day. Thank you so much.
All right. Bye.
Bye.